Hello, tech enthusiasts. Today, we're delving deep into the core of your favorite gadgets, the printed circuit board or PCB. These unsung heroes of the electronic world are everywhere, from your smartphone to your gaming console. But have you ever stopped to think about how they come to life? Buckle up, as we embark on a journey to uncover the secrets behind the creation of these electronic masterpieces. A printed circuit board, PCB, is a foundational component in many electronic devices. It mechanically supports and electrically connects electronic components using conductive pathways, traces, or tracks that are etched from copper sheets laminated onto a non-conductive substrate. The process of making a PCB involves several steps, and the board itself is composed of multiple materials. Here's a brief overview of the process and the materials used. PCB materials. Substrate. Often made of fiberglass, specifically FR4, flame retardant 4, which provides the rigidity and thickness to the PCB. It acts as an insulating layer. Copper. Laminated to the substrate in thin layers, it's used to create the conductive pathways. PCBs can be single-sided, one copper layer, double-sided, two copper layers, or multi-layered. Solder mask. This is the typically green layer that you see on most PCBs. It's an insulating layer that covers the copper to prevent unintended short circuits. It also helps protect the copper from corrosion. Silkscreen. Usually white, this layer adds symbols, letters, and numbers to the PCB for easier assembly and understanding the board's function. PCB manufacturing process. Design. Before manufacturing, a PCB design is created using software. This design is crucial to determine the positioning of components, routing of electrical pathways, and other specifications. Printing. The design blueprint is printed on a special printer, producing what's called a printed PCB. Creation of the substrate. The desired thickness of fiberglass, FR4, is cut, and epoxy resin is applied to hold the layers together. Laminating copper. A thin copper layer is pre-bonded to the substrate. For double-sided PCBs, copper is laminated to both sides. Pattern transfer. Using the printed design, the pattern of the circuitry is transferred to the board. This often involves using a photosensitive coating process where the design protects certain areas from being washed away when exposed to light. Etching. Exposed areas that are not part of the design are etched away using chemicals, leaving behind the desired copper traces. Drilling. Holes are drilled into the board for component leads. These holes will be plated to make them conductive. Plating. Copper is plated onto the surface and into the drilled holes to create pathways for electrical connection. Solder mask application. The board is coated with solder mask, which is then cured to harden it. Silkscreen printing. Relevant symbols, numbers, and labels are printed onto the solder mask. Testing. Before the PCBs are shipped out, they undergo electrical tests to ensure there are no short circuits or broken connections. Breaking apart. In mass production, multiple PCBs are often made on a larger board, which is then broken apart into individual PCBs. Once the PCB is made, electronic components are soldered onto it to create a functional electronic assembly. Advanced PCBs can have multiple layers of copper, sometimes more than 10, to accommodate more complex circuitry. And there you have it. From a simple design to a fully functional PCB, the journey is nothing short of fascinating. We hope you enjoyed this deep dive into the world of printed circuit boards. If you found this enlightening, don't forget to hit that like button, share, and subscribe for more tech explorations. Until next time, keep those circuits buzzing and stay curious.